Welcome to the Planet of Maths channel. In this episode, we will use synthetic division method for dividing polynomials. It's a very cool method, but it's important to remember that this method only works for dividing a polynomial by a binomial, meaning an expression x minus some number or x plus some number. In other cases, this method does not work. To use synthetic division, we draw a table with 3 rows, and the number of columns depends on the terms of the polynomial, meaning the degree of the polynomial. The most important thing in this scheme is this number, and we put this number here on the side, but we must remember to change the sign. So if there is minus 2 here, we put a positive 2 in the table. And here at the top of this table, the coefficients of the successive terms of the polynomial drop accordingly. So the highest 3 drops in this place. The next coefficient is minus 4, and it drops here. This coefficient, minus 8 drops in this place, 7 drops here, and 2 drops here. It goes in sequence: the coefficient of x to the 4th power, x to the 3rd power, x to the 2nd power, x to the 1st power, and the constant term. Then it goes like this. The highest coefficient, which in this case is for x to the 4th power, this 3 will drop down here. At the beginning, nothing happens. Now, we must multiply this term here by that 3 at the bottom. From this we get 6. We write it in the next box, and now we add these 2 terms together. And from this, we get positive 2. And once we have this positive 2 written here, we multiply it by this 2, get the result of 4, and we write it in the next column at this spot. And again add from top to bottom the negative 8 and 4, resulting in minus 4. And then the obtained minus 4 we multiply again by this 2, which gives us a result of negative 8. We add the negative 8 to the 7 at the top, and we get negative 1, and we multiply negative 1 by the 2, which gives us negative 2, and we add negative 2 to 2. When we add them, we get 0. And that's the end of the division. We can now write down, and the numbers we obtained are the coefficients of the new polynomial, except this 3 will be the coefficient not for x to the 4th power, but for x to 1 degree lower, which is x cubed. The next coefficient is plus 2, and this is the coefficient for x 1 degree less than here, which is for x squared. The next coefficient is minus 4, and this is the coefficient. Here it was x squared, so now this will be the coefficient for x. A minus 1 is the constant term of our resulting polynomial. This column is the remainder of the division. In this case, the remainder of the division is 0. Thus, we can write here that the result of this division gives us such a polynomial and there is no remainder. Something like that. And at the same time, we need to know that this original polynomial, this one here, can be written as the product of that which we divided by, which is x minus 2, multiplied by this polynomial, which is the result. That's the end of this example. In example B, we have a polynomial. We need to divide it by the binomial x plus 3. In this case, we need to notice that we are missing some powers. We have x to the 5th power, which is the highest power, then x to the 4th. The coefficient with x to the 3rd is missing, meaning it's 0 here, and the coefficient with x is also missing. So we need to fill in these coefficients here. We rewrite minus 2x to the power of 5, rewrite minus 3x to the power of 4, and here the coefficient at x to the power of 3 is only invisible, meaning it's 0 here. Then the coefficient with x squared is there, so we write down minus 7x squared. Here, x was missing, so we write 0x here. And we rewrite this one. We must be aware that these zeros are here because we will need to insert these zeros into our table. Our table looks just like before. 3 rows. We start with this number 3. Here it's a positive 3, so we copy this 3 here, but it must have a change sign, so it will be minus 3. Then here will be the coefficient of the highest power, which is x to the power of 5. And the minus 2 drops here to the table. The minus 3 drops here to the table. 0 drops here. Minus 7 here. Another 0 here. And finally the 1 at the end. We start with the fact that the highest coefficient at x to the power of 5 drops down to the very bottom here. This is minus 2. We multiply this minus 2 by this minus 3. From this, we get a positive result of 6. We enter this in the next column. We add these 2 terms. When we add 6 and minus 3, we get the result of 3. We multiply the obtained 3 by what was here, which is minus 3. We get minus 9 from this. We add this minus 9 to 0. We get minus 9. And we multiply minus 9 by minus 3. Minus 9 times minus 3 gives us a positive 27. We add this 27 to negative 7, we get 20. Multiply 20 by negative 3, we get negative 60. Negative 60 added to 0 is still negative 60. And negative 60 needs to be multiplied by negative 3, which is 180. Adding 180 to 1 gives us 181. And now we read it like this. This coefficient minus 2 is the coefficient for x to the fourth power, which is 1 less than here. We write minus 2x to the fourth power, and then sequentially, the positive 3 is plus 3x to the third power. Negative 9 is minus 9x squared. Here is a positive 20, so plus 20x. And there is also minus 60, which is the constant term. This is the polynomial that we obtained, but additionally, we also get a remainder here. So we write this result in this way. We rewrite the entire expression, but here we also need to note that we ended up with a remainder equal to 181. And that means we can write this polynomial as follows. This initial polynomial is the product of what we divided by, which is x plus 3, multiplied by this entire polynomial, which was the result. But here we also have the remainder. This remainder is positive, so we write plus 181, and that's the end of this example. Example C, we need to divide this polynomial by the binomial x minus 5. We have x to the power of 5, x to the power of 4, x to the power of 3. We are missing the term x squared, which means that here it will be 0x squared. So our polynomial, which we will put in the table, will be 2x to the fifth unchanged. Here unchanged, unchanged. Here we add 0x squared, and the rest we copy, which is plus x minus 3. And only now, after such completion, we make a table. We put this number 5 into the table, but with the opposite sign, so it will be a positive 5 here. 2 drops, minus 7 drops, minus 15 drops, here 0 drops, here the one that was invisible drops, and the number minus 3 also drops. These are coefficients for such x's. The 2 from above, the highest coefficient, falls down for us to know what to multiply by. We multiply this 2 by 5, get a result of 10, and we add this 10 to what we have above, which will be 3. The 3 we obtained, we immediately multiply by 5, we get 15. 15 and minus 15 gives us 0. 0 times 5 is 0. We add these two zeros and we have 0 again. 0 times 5 is 0, we enter it here. We add this 0 to 1, that is 1. We multiply 1 by 5, we get 5. 5 and minus 3 is added, resulting in 2. Then we read from the table. Here at the top, the 2 was the coefficient for x to the fifth, so the 2 at the bottom will be the coefficient for x to the fourth. We will have 2x to the fourth power. Then there is a positive 3, so plus 3x to the third power. Plus 0x to the power of 2, so we don't need to write that. Plus 0x to the power of 1, so we don't need to write that either. Then we write this term. This is the constant term. There wasn't x squared, there wasn't x to the first power, and only the constant term appeared. And we still have the remainder from the division in this example. We write down the result. The result is this polynomial, and this time again we have a remainder. This remainder here is 2. This is the first way to write the result of this division, and the second important way to write it. This initial polynomial, it will be equal to some product, so we write it down. This initial polynomial is equal to the product of this by which we divided by, meaning x minus 5, multiplied by the result, which is this polynomial here. And outside the parentheses, we add the remainder if there is one. In this case, there is a remainder. It is a positive remainder, so we add plus 2. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Math channel.